Good morning, good afternoon, everyone. My name is Sanjay Suresh, and I'm a student at University of New England taking biochemistry course MBS 650. Today in my video, I'm going to talk about two case studies. The first one is the case study about muscle glycogen phosphorylase deficiency. That is the case about the 16-year-old. I believe it is case 2. So basically, the case study is saying that we have a 16-year-old female who is diagnosed with the deficiency of muscle glycogen phosphorylase, and her and her family are concerned about the risk, and they have certain questions. So basically, since the fact that we've been diagnosed with deficiency of muscle glycogen phosphorylase, we also have to know what it's called. So it's called myophosphorylase deficiency. So this myophosphorylase is basically an enzyme that is essential for our muscles, and which accesses the store of energy during exercise. So while talking about this, I'd like to answer some questions. First of all, what does this enzyme do normally to our muscles? So our muscles basically stores energy in the form of glycogen, which is glucose molecules that is built up in the muscles and liver. And once we start exercising, our muscles quickly need energy. So our body slowly starts to release these glucose molecules, which are stored as glycogen, and these get broken down and they are used as fuel. So the main problem with this enzyme deficiency is the deficiency of muscle glycogen phosphorylase. So breaking down, this enzyme mainly breaks down glycogen into glucose 1-phosphate, and so glucose can enter into the cell. It can enter in to start glycolysis. So what happens? So without this enzyme, our muscles cannot efficiently release this glycogen during exercise. So basically what happens when you start exercising? Well, the first thing that happens is the energy demand starts to raise, and our muscles need ATP. Also, we have some hormonal changes. For example, adrenaline, which increases during exercise. The calcium content starts to increase because of muscle contractions. And then we also have something called AMP, that's adenosine monophosphate level, which increases, which is a sign of low energy. And so we have the activation of glycogen phosphorylase. And basically, why do we feel muscle cramps during exercise? So muscle cramps mainly occur because the early exercise energy, it comes through gluconeogenesis, and which means breakdown of glycogen, and then it enters glycolysis. So in this case, glycogen cannot be broken down. So the muscles switch. Muscles have to switch to blood glucose and fat metabolism. So this leads to lower energy and ATP availability during the exercise. So this results in muscle cramping and fatigue. And why do we feel better after resting and warming up after an intense training? This is very important in this condition. So after a few minutes of exercise, our body starts to increase the blood flow. So more glucose and fatty acids start to arrive in the bloodstream, and the muscle starts to muscle metabolism starts to occur, and then it shifts to aerobic metabolism. So glycogen cannot be used. So even though glycogen cannot be used, we do have fuel sources that do get activated, and it helps us keep going. The next question is, can our muscles still make up energy at all? Certainly they can, because our muscles still have other energy pathways. So For example, the fatty acid oxidation. Our body does utilize fatty acids and ketone bodies, which mainly occurs in the mitochondria. And we also have something called as ATP-PC system, which uses stored phosphocreatine, which works for only a few seconds. Only a few seconds. So, what does it mean for our life? So, most people with this condition, they live normally with normal lifespans. They learn to manage exercise levels and they try to avoid certain aerobic activities. So while exercising, gradual warm-ups before exercise, you want to avoid sudden high-intensity activities and regular modern aerobic exercises. This should all be avoided. So the next case study, that's case study 3, we have the neonatal hypoglycemic infant with seizures. So basically, we have a baby here, which is having seizures, and so we need to act immediately to stabilize this child. So this could be a treatable condition, and here we are to help the child right away. So what are we going to explain to the mother? We need to explain to the mother that the symptoms are the baby's symptoms, which are weak, poor feeding, crying, and now seizures. This is due to low blood sugar levels. This is also called as hypoglycemia. So typically we confirm hypoglycemia when the glucose levels are about from 25 to 28, and this child requires more glucose. So why does this happen? We have to explain that the blood glucose was high because of gestation diabetes, and because of that, the baby was exposed to high glucose in the womb, and in response, the pancreas started to produce more insulin, and this led to low glucose levels. So a biochemical explanation, we have to explain to them the enzyme systems that act for glucose storages were highly active in the womb. Mainly this includes glycogen synthase, which stores glucose as glycogen in the liver. But the insulin levels still remained high for quite a bit. So what happened here? So we have high insulin, we have too much glucose that is uptaken by the cells and it is not distributed. And then we have too little glucose in the blood, which leads to hypoglycemia. So this is called neonatal hypoglycemia. And why do we have seizures? Well, the brain depends completely on glucose. So if there's low glucose, then our brain cannot produce ATP, and then this leads to electrical instability. For example, there's shaking, poor feeding, lethargy, and seizures. So what are some other laboratory findings? We have a high hematocrit that is 68. That means that this child could be having a condition called polycythemia vera. That means that most of all the red blood cells, white blood cells, everything is high. This can happen in diabetic mothers to reduce oxygen levels in the womb. Also, there's low calcium. It's approximately 7. So this can lead to hypocalcemia. There's tremors, seizures, and we need to correct the situation. And also we have high bilirubin levels. So what is the treatment? We need to monitor the glucose closely. We need to give glucose infusions, and if possible, we need to treat the calcium and glucose. And we also need to ensure feeding support. So coming to the reassurance, the most important part is this condition can be treated, and once stabilized, most babies recover well without long-term effects, especially when we treat them promptly, as we're doing now. So this is all about my case study, and I really hope that you enjoyed my video, and then please subscribe to my channel and let me know how this video went. Thank you so much, and I'll be making more videos in the future.